Welcome to a new problem solving session. Basically, these questions were initially provided on the YouTube to solve the students. These questions are basic, simple questions, like they are based on ray optics, and that means the rectilinear propagation of light and simple application of reflection. So I'm going to provide you here a set of problems and I'm going to solve them all. Few of the problems are related to IE Rodo because some people sent me a kind of challenge that Irodo has provided some good problems based on the vectors, and well, vectors can be always related to the rectilinear propagation of light. And can you solve it? Can you provide your angle on it? Yes, I think I can do whatever my angle is, I can provide it. So I'm going to solve few problems right here, and here is the second problem in this series. And as you can see on the screen that there is the statement of the problem, and that says two small flat mirrors, that means plane mirrors, are located at equal distances from each other, right? Try to make a picture of the problem. And from a light source, that means they are at equal distances from each other and also from a light source. That's right. What should be the angle alpha between the mirrors so that the beam, after two successive reflections, that means we have to consider two reflections one after another, it returns to the source. This is the first case, that means it returns to the source itself. And the second problem is return to the source retracing its path. That means so जैसे आया था वैसे ही चला गया. Source, the beam retraces its trajectory. This is the second case, and first case mein it simply reaches to the source itself. So I have drawn pictures, drawn diagrams for the solution of these two problems, and let us see how are we going to solve it. So focus on solving now. And you can see here I have placed the statement of the problem and the supposed solution diagram for this problem side by side. And we just need to follow the problem, a statement of the problem. These are the two mirrors, and in the first case uh, it is being asked that what should be the angle between these two plane mirrors so that the ray returns to the source itself. That means it is going to make an equilateral triangle, and you can see here if it makes an equilateral triangle to return to the point S, this 2 phi angle indicated in the figure must be equal to 60 degree. That means phi will be equal to 30 degree. And since you can see from here that this is the normal to this mirror, and that means gamma plus phi should be equal to 90 degree, and that explains gamma equals 60 degree. And since 2 gamma plus alpha is equal to 180 degree, and that means alpha is equal to 60 degree, because 2 gamma becomes 120 degree, and 180 minus 120 is simply 60 degree. So first case is quite clear here. In the second case, you know, it requires that it is asked in the problem that what should be the angle alpha between the mirrors so that the beam after two successive reflections returns to the source, retracing its trajectory. And that means when the ray retraces itself, that means it return to the source, the beam must fall on the second mirror perpendicular to its surface like this. This would be 90 degree right angle. And if this is the case, alpha is already equal to phi is already equal to 30 degree, then from this triangle, you know, gamma plus 90, gamma is already, I guess, gamma is already equal to 60 degree, so that means 60 degree plus 90 degree plus alpha, and that will be equal to 180 degree, and that gives you alpha equals 30 degree. So in the first case alpha is going to be 60 degree, and in the second case alpha is 30 degree, as you can see in the solution diagrams. And that's all. This problem is quite simple. Thank you very much for watching.